What if I told you nothing is solid? Time might not be real, and you are not who you think you are. Right now, your brain is hallucinating your reality, and you're calling it life. From subatomic particles that vanish when you look at them, to memories that change every time you recall them, science is revealing truths stranger than fiction. Let's start with the basics. Everything you see, hear, feel, it's not the raw world. It's a reconstruction. Your eyes receive photons, your ears pressure waves, your skin vibrations. None of that is reality. It's just data, meaningless until processed. And that processing, that's where it gets weird. Particles appear out of nowhere. Time bends. Your brain rewrites history, and you don't even notice. You're in a biological machine designed not to show you truth, but to keep you alive. So ask yourself this. If your senses lie, if time warps, if matter is mostly emptiness, what is real? Welcome to the edge of understanding, where quantum mechanics, neuroscience, and illusion collide. Stay with me, and we'll bend your reality using real, peer-reviewed science.
This is Perception Lab. And if you're the kind of person who loves black holes, alternate dimensions, or just questioning everything, you're in the right place. Today, we're asking the big questions. What is reality? Can we trust our senses? Is consciousness just an illusion? And could we be living in a simulation? Science has reached a point where its findings sound indistinguishable from science fiction. But this isn't fiction. These are peer-reviewed papers, lab experiments, Nobel Prize-winning discoveries.
What if I told you nothing is solid? Time might not be real, and you are not who you think you are. Right now, your brain is hallucinating your reality, and you're calling it life. From subatomic particles that vanish when you look at them, to memories that change every time you recall them, science is revealing truths stranger than fiction. Let's start with the basics. Everything you see, hear, feel, it's not the raw world. It's a reconstruction. Your eyes receive photons, your ears pressure waves, your skin vibrations. None of that is reality. It's just data, meaningless until processed. And that processing, that's where it gets weird. Particles appear out of nowhere. Time bends. Your brain rewrites history, and you don't even notice. You're in a biological machine designed not to show you truth, but to keep you alive. So ask yourself this. If your senses lie, if time warps, if matter is mostly emptiness, what is real? Welcome to the edge of understanding, where quantum mechanics, neuroscience, and illusion collide. Stay with me, and we'll bend your reality using real, peer-reviewed science.
In this video, we'll move through the building blocks of your perceived world, from quantum mechanics to your brain's inner workings, and show you how fragile, how bizarre, and how constructed your experience of reality really is. You'll learn why your memories are unreliable, why you never really touch anything, why particles seem to know when you're watching them, why your brain is constantly lying to you, but for good reason. For the next few hours, we're diving deep through quantum weirdness, illusions of the mind, and the architecture of consciousness. These are the bizarre scientific facts that challenge everything you know. By the end of this video, you'll see reality in a way you never have before. Or maybe, just maybe, realize there is no single reality at all. Let's start with something simple. Your hand. Seems solid, right? So does the chair you're sitting on. But zoom in far enough, and you'll find almost nothing there. Atoms, the building blocks of matter, are 99.9999999% empty space. The solidity you feel is just electromagnetic repulsion. You're not really touching anything. You're hovering on invisible fields. Let's get technical for a moment. Inside every atom is a nucleus made of protons and neutrons, orbited by electrons. But those electrons don't have definite positions. They exist in a probability cloud, a wave function. You can't point to where the electron is, you can only calculate where it might be. That brings us to one of the most famous experiments in science, the double-slit experiment. Fire a stream of particles, electrons, photons, at a barrier with two slits. Behind that is a screen. When you don't observe which slit the particles go through, they create an interference pattern, as if each particle is going through both slits simultaneously, like a wave. But when you place a detector at the slits to observe their path, the interference pattern disappears. They behave like particles again, one slit or the other. Why? Because the act of observation collapses the wave function. The particle is no longer a maybe, it becomes a here. This is the observer effect. It's not that the particle changes because you looked, it's that reality, on a quantum level, doesn't take on a definite state until observed. And it doesn't stop there. Entanglement, another quantum phenomenon, links particles so closely that the state of one instantly determines the state of another, even if they're light years apart. Einstein called it spooky action at a distance, but it's been proven over and over. So what does that mean? That at the smallest scales, reality isn't made of things, but of probabilities, possibilities, waves of potential. It means the universe is more fluid, more dynamic, and far stranger than we were ever taught in school. And yet, all of this underpins everything you experience. The atoms in your body, the photons in your eyes, the quarks in your thoughts. Everything you are is a shimmering blur of possibility, temporarily collapsed into something that feels solid. So now we shift from the quantum world to the one behind your eyes, your brain. And here's the kicker: your brain doesn't show you the world as it is, it shows you a guess. Every second, billions of bits of sensory data flood in, but you're aware of only a sliver, a carefully crafted, high-efficiency illusion tailored for survival, not truth. Take vision. You think your eyes are cameras, faithfully recording reality. They're not. They're filters. The raw image sent to your brain is full of gaps, distortions, and noise. Your brain takes this mess and reconstructs a coherent world. It guesses what should be there based on memory, context, and prior experience. That's why you don't see the blind spot in your retina. Your brain fills it in. That's why optical illusions work. They hack the brain's predictive model. And here's where it gets really strange. It's not just vision. All of your senses work this way. Your perception of time, constructed. Your memory of this morning, edited. Even your sense of self, a constantly updated narrative stitched together moment by moment. Take the checker shadow illusion. Two squares, same color, one appears darker. Why? Because your brain factors in shadow and light, not actual color data. Or the dress. Is it blue and black or white and gold? Depends on what your brain expects based on lighting context. Your brain doesn't just passively receive the world, it actively predicts it. This is the basis of predictive processing, one of the most powerful ideas in neuroscience today. The brain is a prediction engine. It generates a model of the world, updates it with sensory feedback, and minimizes errors. In other words, you don't see the world, you see your brain's best guess. And when that guess is wrong, you experience illusions. But it goes deeper. Hallucinations, dreams, déjà vu. These are all cases where the brain's predictions override sensory data. Meaning, your experience of reality isn't something you observe, it's something you generate. So the question becomes, if your brain can hallucinate without drugs, without illness, without even trying, how do you know this isn't a hallucination right now? And what does that mean for your idea of what's real? Let's go deeper still into time, selfhood, and consciousness itself. You probably think of time as a flowing river, steady, constant, always moving forward. But physics paints a much stranger picture. Let's start with relativity, Einstein's revolutionary idea that time isn't absolute. It bends, it stretches, it dilates. Clocks tick slower near massive objects, move fast enough, and time slows for you relative to someone standing still. This isn't theory, it's fact. GPS satellites have to correct for time dilation every day, or their data would be inaccurate by kilometers. This means your experience of time is not universal. There is no single now. Imagine two astronauts passing each other in space. Each one sees the other's clock ticking slower, and they're both right. That's what relativity says. Then there's the block universe theory, the idea that all of time exists simultaneously. Past, present, and future are equally real. You just experience it one frame at a time, like playing a movie reel. From this view, the passage of time is just a psychological effect, a product of consciousness moving through a four-dimensional space-time landscape. Now zoom into the brain. Your brain is not a clock. It doesn't sense time directly. It constructs it. The present moment, what you call now, is actually a brief window around 2 to 3 seconds long within which your brain groups events into one coherent experience. Outside of that window, events blur. Some fade into memory. Others never even register. Ever slammed on the brakes and felt time slow down? That's called time dilation under stress. Not because time changes, but because your brain stores more detail, creating the illusion of slowness. Ever noticed how time flies when you're in flow, but drags during boredom? That's your brain modulating its attention and memory density, not external reality. Your experience of time is elastic. And here's the kicker. Recent experiments with neuroscience and quantum cognition suggest that your brain may even process time backward, retroactively deciding the cause of an event after it has already happened. In one study, a stimulus presented after a choice influenced how people reported making that choice. It's as if your brain rewrote history. Which begs the question, if your perception of time is editable, is time even real? Or just another construct, like color, taste, or self? From Einstein to entangled particles to internal clocks in your head, every clue we have suggests the same mind-bending truth. Time isn't what you think, and what you call now might be nothing more than a useful illusion. So far, we've deconstructed matter, perception, and time. But now, we arrive at the deepest mystery of them all: consciousness. That inner voice narrating your life, the feeling of I, the awareness that's watching this video. What is consciousness? Where does it come from? And perhaps more hauntingly, why does it feel like anything at all? This is known as the hard problem of consciousness, coined by philosopher David Chalmers. It asks, why should physical processes in the brain give rise to subjective experience? You can explain how neurons fire, how information is processed, how muscles move, but none of that explains why red looks red, why chocolate tastes like chocolate, why anything feels like anything. And yet, you know intimately what it's like to be you. You don't need proof. Consciousness is the one thing you cannot doubt. Let's dive into the science. One theory is the global workspace theory, or GWT. It suggests consciousness arises when information from different brain systems, vision, memory, emotion, enters a central workspace and is broadcast to the rest of the brain. Only the information that makes it to this spotlight becomes conscious. Everything else, most of what's happening in your brain, remains unconscious. Then there's integrated information theory, IIT. It proposes that consciousness corresponds to the degree of information integration in a system. In other words, the more interconnected and differentiated a system's parts are, the more conscious it is. According to IIT, consciousness doesn't require a human brain. A sufficiently complex network, biological or artificial, could theoretically be conscious. And then there's panpsychism, a radical idea gaining traction. It suggests that consciousness isn't something that emerges at a certain complexity, but something fundamental to the universe, like space, time, or mass. If that's true, then everything, atoms, electrons, maybe even quarks, has a tiny spark of awareness. Sound crazy? Maybe. But the hard problem demands bold ideas. Let's turn to real-world experiments. Split brain patients, people who've had the connection between their brain hemispheres severed, sometimes exhibit two separate consciousnesses in one body. One side can see and respond to information the other can't access, and they often disagree. This suggests consciousness isn't unified. It's modular. It can be divided. In patients under anesthesia or in comas, Brain scans sometimes reveal coordinated activity even when no outward signs of awareness exist. Some patients have been able to communicate via fMRI by imagining certain actions, like playing tennis. That means consciousness can be hidden, silent, but still there. Let's zoom back in on you. Right now, your brain is running thousands of unconscious processes, regulating your heart, interpreting this voice, tracking background sounds. And yet, you experience it all as a seamless now. But that sense of self, that you, it's an illusion too. Neuroscientists describe the self as a narrative, a useful fiction generated by the brain to unify your memories, goals, and sensations. There's no central you watching the show, just a stream of processes integrated well enough to feel like a single entity. Your preferences, your personality, your identity, these are patterns, stable, but not fixed. Let's run a thought experiment. Imagine slowly replacing every neuron in your brain with an artificial one, identical in function. At what point do you disappear? If your behavior, memories, and thoughts remain identical, is it still you? Or consider this. If consciousness emerges from complex information processing, could a sufficiently advanced AI become conscious? Could we build a mind? And if we can't define what consciousness is, how would we even know if it happened? Some scientists argue that we'll only recognize machine consciousness if it starts suffering, if it develops preferences, fears, a will to survive. But that raises ethical questions. If we create minds capable of pain, do we owe them rights? Here's another twist. What if the universe itself is conscious? Some cosmologists speculate that consciousness may be a field, like gravity or electromagnetism, that pervades space. If so, your mind isn't a thing inside the universe. It's a pattern in the universe, a way the cosmos has come to know itself. As Carl Sagan once said, we are a way for the universe to know itself. And that brings us full circle. You are not just atoms, not just neurons, not just stories. You are awareness, peering out through a mask of matter, wondering what it means to be. And no matter how much we explain, there's something ineffable at the core of it all, something we might never fully grasp, but which we are nonetheless. Consciousness is the last great mystery, and maybe the key to everything else. Now that we've explored quantum matter, warped time, hallucinated perception, and the mystery of consciousness, we arrive at one of the most controversial, mind-bending ideas ever proposed, the simulation hypothesis. What if this entire universe, the galaxies, the stars, your body, your memories, is a highly advanced simulation? Not a metaphor, not a dream, a literal programmed reality. This idea was formalized by philosopher Nick Bostrom, who proposed a trilemma. Either advanced civilizations never survive long enough to simulate ancestors, or they choose not to, or, and this is the unsettling part, we're probably inside one right now. Let's unpack this. We already simulate simple versions of life. Video games render entire worlds. AI creates deepfakes, personalities, even voices. Every year, our simulations grow more complex. Now imagine what happens in 1,000 years or 100,000. A civilization could simulate entire conscious beings like you, with internal thoughts, memories, and agency. Not out of cruelty, but curiosity. A history project. A research tool. A digital zoo. How would you know? Let's look at the evidence, starting with the quantum. The universe has a pixel size, the Planck length, the smallest possible unit of space. Reality isn't infinitely divisible. It's quantized, like digital code. It also has a refresh rate, the speed of light. Nothing goes faster, not because of physical resistance, but as if it's the limit of processing power. When we observe particles, they collapse into a fixed state, just like how a computer only renders objects the moment you look at them in a video game.
Even more uncanny, entangled particles can influence each other instantly, across vast distances. This breaks all classical understanding. But in a simulation, this could be how a unified system maintains internal consistency.
And remember the quantum vacuum, a sea of probabilities that give rise to form? That sounds an awful lot like background processing. Constant fluctuations, minimal energy, high information density. In short, nature behaves like code. Some physicists, like the late John Archibald Wheeler, believed information is more fundamental than matter or energy. He coined the phrase, it from bit, that everything, even particles, emerges from binary yes-no choices, the building blocks of computation. But let's go further. Have you ever experienced a coincidence so perfect it felt scripted? A moment where reality seemed to glitch? Some interpret these as evidence, not proof, but hints that the simulation isn't perfect, that anomalies, edge cases, and bugs appear just like in any software. Then there's the Fermi paradox. If the universe is so old and vast, where is everyone? Maybe we're isolated on purpose. Maybe this is a test environment. Or maybe we're the only sentient ones because the rest is procedural filler, simulated only when necessary. Even our sense of self fits. Remember, your brain builds a model of reality using data. You never interact with the world directly, only your simulation of it. You're already living inside a model, your own brains. So even if the universe isn't literally a simulation, your mind already is. Now, let's confront the implications. If we're simulated, does it matter? Well, yes and no. If consciousness arises within the simulation, then your experiences are still valid. Your pain is real. Your love, your questions, your memories, they matter. But it also means there may be layers to existence, realities stacked inside realities. If we are simulated, perhaps our simulators are too. Infinite recursion. Some spiritual traditions have said this all along, that reality is Maya, an illusion, that we're dreaming, and awakening is the goal. Maybe the mystics were describing the simulation before we had the language for it. Or maybe we're simply part of a vast, evolving multiverse, and simulation is just one possible lens. Either way, the simulation hypothesis reminds us that our assumptions about life, the universe, even our identity, are fragile. It forces us to ask, what do I really know? What if the universe isn't built from atoms, but questions? And what if the answer depends on whether you dare to look deeper? Whether simulated or not, your awareness is here. And maybe, just maybe, that's the only reality that truly matters. So, we've traveled through the quantum fabric of matter, bent the flow of time, unmasked the illusions of the mind, probed the nature of consciousness, and even questioned the very simulation we might be living in. And now, we loop back to the biggest question of all. What is real? Is it atoms and forces? Bits and code? Brain states? Or something deeper, more elusive? Let's take stock. Matter isn't solid. It's vibration, probabilities, empty space. Time isn't linear. It's relative, psychological, possibly illusory. Perception isn't truth. It's hallucination guided by prediction. Consciousness isn't explainable, not fully, not yet, maybe never. And even the universe itself might be a simulation, a layered illusion inside another illusion. So, what is real? Here's one possibility. Reality is not a thing. It's a process, a relationship, an interaction between the observer and the observed. Like a quantum particle, it doesn't exist in one definite state until we engage with it. You're not standing on solid ground. You're surfing the crest of a wave, moment by moment, sculpting meaning from chaos. You are not separate from the universe. You are of it. A brief flare of awareness reflecting on itself, in awe, in confusion, in wonder. And in that, maybe we find the truest thing there is. Not certainty, not facts carved in stone, but curiosity, the hunger to ask, the courage to doubt, the wonder of not knowing. So, as this journey comes to an end, maybe the real mission isn't to find the answer, but to never stop asking the question. If your mind feels a little bent right now, good. That means you're alive, awake, still asking. Which idea blew your mind the most? Leave it in the comments. Let's talk. Like this video if it sparked something in you. Subscribe if you want more long-form explorations into the edges of reality. And most importantly, stay curious. Until next time, keep questioning everything because reality is not what it seems.